guys, because it makes you think like on 2 layers instead of just applying the formula directly, right? Okay. So a sound wave is created by a transducer, reflects off an object, and returns to the transducer. The goal and return time is 130 microseconds. What is the maximum PRF, right? So it's only giving us the goal and return time. We know the formula for PRF is 77,000 centimeters divided by the depth, right? So it giving us our goal and return time, we have to determine what the depth is by applying our 13 microsecond rule, right? So we take our 130 microseconds divided by our 13 microsecond rule. That's going to give us our reflector depth, right? What is that?
10 microseconds.
10, exactly, 10 microseconds. So now we know the depth of the reflector. So now we can figure out the formula for the
10 centimeters or 10 microseconds?
for we're 10 centimeters. I'm sorry, 10 centimeters, because we've got the depth of the reflector. So now we have the depth of the reflector at 10 centimeters. Now we can apply our formula to figure out what the post-repetition frequency is, which is 77,000 centimeters per second divided by 10 centimeters. And that's going to give us 77,000 hertz. I really like that question because it applies the lecture on a different level. You have to figure out the depth first. Yeah, it's a 2-step problem. You have to figure out the depth first, and then to figure out the PRF. Okay. So again, guys, know these equations. Know these equations up here. Know these equations. Okay. I'm going to start on our Transducer chapter again. This chapter right here, guys, that's the end of our physical properties of ultrasound formation, of pulse formation, like a beam formation. Okay. Now we're going to get into something you guys are going to love, I hope, which is more something more tangible or something more related that you can see what we do. Okay. Any questions on the 13 microsecond rule?
So the next question is going to be, the next chunk, two together?
These 2 chapters, yes, ma'am. Sure will be.
So Monday test or Monday test?
Monday test? I don't know. It depends if I get to. Like I said, remember I told you, I said I have to do some manipulating of the schedule now because we're kind of off track a little bit. You know, so it just depends. I gotta see. If I can't get through the Transducers chapter comfortably, then no, we're not gonna have a test Monday because I want to make sure we understand, you know, what the backing material is, what the matching layer is, what the PZT is. So we have to understand it. So the test may or may not be Monday. Right now, just go with a tentative schedule. I'll let you know. If it's gonna be Monday, I'll let you know Friday. It'll be Monday.
Today is the Friday.
Oh, then heck, I mean, heck no, we're not having the test Monday. It's just impossible. We're definitely not having the test Monday. I wouldn't be you guys like that. Okay. So sound travels again, guys. 13, 1 centimeter for every 13 microseconds. Okay.
The 13 microseconds is like a total, right?
Yeah, it's the go and return. It's the time of flight. It's the time of flight. Absolutely. Absolutely. And we can determine our reflector depth by applying the 13 microseconds. We can determine what our PRP is because our PRP is the time of flight. And we know that we can determine our PRF because it's inversely related to the PRP. So we can also determine
Say that the time of flight is
PRF.
Yeah, so the chapter
Absolutely. Just like if I get to this reflection of this king right, so y'all talking too loud. Sophie, bring it down. If I get to this kidney right here, and it's however if it's 2 centimeters deep, that means it's that time of flight took 26 microseconds. So definitely it's applying to the depth of that reflector. If you happen to see that posterior border of the liver right here, you know, and if we know it's at a certain depth, whatever depth, it can be 10 centimeters deep, then we know that sound travels 130 microseconds. Okay. All right, you need me guys after class, I will be here. I will be here. So now, let's start on this Transducers chapter. I didn't send you guys this, right?
Not yet. Not yet.
Have y'all read anything about it?
It's only the video that you sent us about the
I sent you a video on Transducers on
chapter 8, actually.
When I seen it was that's how those videos are on YouTube.
Yeah.
If you look at those YouTube videos, they're really dry, really kind of drab, you know. But hopefully, when I get time, my man Dewey helps me out, I can make some more exciting, cool videos concerning ultrasound physics. But there are some good ones. Like if you look up Exam Refresh has some really nice videos, guys. So if you're on YouTube, use that source, Exam Refresh, okay? Exam Refresh. Let me fix this real quick. So I'm not gonna get too deep on it. I'm just gonna talk about the parts of the transducer.
All kind of transducer.
Alrighty, these are all our transducers right there, guys. You may recognize these transducers, right? All of our transducers, from our little sector probe, you know, our linear probe, to our curved probe, all the way to our transvaginal and prostate probe right there. That's a prostate probe. It's like a mechanical prostate probe based on how big the bulb of the head of that transducer is.
The third one from the below is the 3D, right?
Yeah, it's a 3D probe right there. If you're at LBJ, I know it has a big dome on it. I love that probe because you can look at trans and long images at the same time.
That's cool. What
You
3D?
can split the screen and it'll have you look at. You can be scanning the transverse. You can see your transverse image, but it can also look at your long image at the same time. You can also roll this. It's like a line on there where you can roll it, and you can. While I'm scanning the transverse, I can also look at my long and medial and lateral just by putting this line in different places on the transverse kidney. It's pretty sweet.
So why are we not using this?
Because we need uniformity in the ultrasound department. So we just have one transducer and only one person using it, then that's not uniform. Everybody's not doing the same thing. So that's why that probe always dusty, right? Nobody uses it. I used to use it, but I got in trouble for using it because I was the only one doing something different. So if that's how ultrasound departments are. Everybody has to be. It's a protocol for a reason, right? That's why you all are learning the images to take them in that same order. Really, you can take that protocol anywhere you go because all of those are the required images for an applicant.
Question.
Yes, ma'am.
For the prostate one, how do you use it for the guys?
You stick it in the rectum. Yes. Wait.
Are they on the bed?
They're in the Q position, and you tell them to take a deep breath. Boop. And you look at the prostate, just like you look at the uterus.
But that's where the power is. So how is it gonna go in?
What do you mean? How's it gonna go in? How's it gonna go into the rectum?
They got
You
blue.
put it in there.
They got
That's
blue.
where the poop is. Poop.
It is. Sometimes you pull a transducer and it may have poop on it. You never know. Just like when you pull a transvaginal transducer, it may have
It's not
blood
the
on it.
same. No, it's not the same.
It's not the same, but it's the same.
It's in my crib.
Alright guys, so this chapter right here, guys, focusing on transducers. Basically, transducer construction, what makes up the transducer, and what all the parts of the transducer function as, or what they do. Okay, so it's not telling us the difference between different transducers, not telling the difference between these transducers, because all these transducers have different makeups. But all ultrasound diagnostic transducers basically have the same components within them. You know, that's what this chapter here is about. So ultrasound transducer construction is what this chapter here is about. And we're going to describe the ultrasound transducer construction and its 7 components. We're also going to learn about what the piezoelectric effect is, right? Because we already kind of touched that in intro, right? Mm-hmm. Piezoelectric effect is a material that if it's a pressure's applied to it, then it can create electrical energy. Okay? It's a material that when pressure's applied to it, it can create electrical energy. Okay? So remember our piezoelectric material. We have our pressure would be our sound waves, right? So once those reflected sound waves come reflected back from the body, it hits our crystals, it's applying pressure to them. they have the ability to create electricity, okay? And that's how we get our image, all right? So that's the piezoelectric effect. So it kind of works the opposite of what you think, right? Because you would think the electricity from the wall sending sound waves, applying pressure to those crystals, and they're making sound waves, right? But that's called the reverse piezoelectric effect, okay? When electrical energy is turned into sound energy. This is what we do. That's the reverse piezoelectric effect. The piezoelectric effect is pressure being applied to piezoelectric material, and it's creating electricity. Okay? So, our piezoelectric effect happens during reception, and our reverse piezoelectric effect happens during transmission. Okay? We good there, President? It's a lot on your birthday. I know you probably thinking, oh, man, I just got a monster weekend.
It's tomorrow, but it's tomorrow.
Then that's what you're thinking about. Okay? And we're also going to discuss transducer frequencies, difference with continuous waves versus pulse waves. Okay? So like again, we're talking about the makeup of a transducer. All right? So, not to just think a transducer is just what we use in ultrasound. There's many different kinds of transducers. A transducer is just any device that converts one form of energy to another form of energy. Okay? You guys use a transducer every day in everyday life. You drive your car. Okay? It's taking that gas, that chemical energy, turn into kinetic energy, right? Because we're driving now, right? So transducer is just anything that converts one form of energy to another form of energy. Okay? So our transducer has two functions: transmission and reception, right? On and off time, talking and listening, right? So during transmission, electrical energy from the system is converted to sound, right? Because we have our machine plugged up to the wall. That's our electrical energy. That's what is sending out pulses to our transducer, to our piezoelectric material. And then when those piezoelectric materials are excited, it creates sound waves. Okay? Those sound waves travel into the body. Then they bounce back for reception. Those reflected sound waves are converted back to electricity when those pressure waves come back, hit our piezoelectric material again, hit our transducer again, and now those sound waves are converted to electricity. Okay? So, two functions of the ultrasound transducer: transmission, reception. All right? So, here goes my example right here, guys. Here's our electrical pulse. This is transmission right here, guys. This is reception. Of course, look at our direction of our sound is traveling to the organ, back to the transducer. So our electrical pulse from the wall is going to be transmitted through the transducer. Here's our piezoelectric material. It's going to excite it. It's going to vibrate it. It's going to cause it to move, and then it's going to produce sound waves. Okay, those sound waves are going to go into the body. They're going to bounce off the organ, come back as sound waves. Those pressure waves are going to excite this piezoelectric material, and then that's going to create electrical energy. Okay, that electrical energy goes back to the transducer, to the machine, then the receiver and all the pulsar and the beamformer does all this work, and it creates an image for us. Okay. Transmission, ultrasound transducer converts one form of energy to another form of energy. Okay, two functions of the ultrasound system: transmission, reception. Okay. Boom. These are examples right here of different kinds of transducers. Okay, just so we don't think that, hey, it's just our ultrasound transducer. So, of course, doing ultrasound transmit, electrical energy is converted to sound waves, acoustic energy. Okay, doing reception, acoustic energy is converted back to electrical energy. Okay, so like I said, our car engine converts chemical energy to motion or kinetic energy. Right, our electric motors convert electricity from the wall to motion. I was just, I don't know if you I was using a blower at my house today, and I have an electrical blower because I have acorns all over the place. The squirrels are killing me, and my blower is really weak. I'm like, man, what's going on with my blower? And so I didn't have it plugged in all the way, so I wasn't blowing anything for a long time. I ended up sweeping before I realized, man, the thing ain't even plugged in all the way. Goodness. Okay, so we have our light bulbs convert electrical energy to light and heat energy, right? And we're talking about our flashlight. Okay, and we have our muscles. They're converting chemical energy in the body to motion. Okay, that's how we're able to move around and stuff like that. Right?
You mean the transducer is
your
You're
muscle.
talking about conversion or about the transducer, the machine?
I'm talking about energy
Any-
conversion,
oh,
any
okay.
transducer. Any,
Mm.
all of these are considered different types of transducers right here.
At the muscle?
Yes.
Transducer?
Absolutely. Because the transducer is simply,
Offline.
you weren't listening when I said,
Yeah.
transducer is simply
Yeah.
something that converts energy from one form to another form. Okay?
Yeah.
Good. Alright? So, this is our basic transducer construction, guys, we're gonna talk about right here. I'm not gonna hold it, I'm gonna talk about this slide right here, and I'm gonna let you go, okay? So, our ultrasound machine, again, I already said, it has 7 basic components to our ultrasound transducer. Okay? Guys, you may have to label this image, right? Guys, you may have to label this image, okay? Guys, you may have to label this image. So know this image. So know this image.
So you know.